Today's topic is about one of the Java built-in functional interfaces, the supplier. But before we talk about the supplier, let's briefly talk about the Java built-in functional interfaces. Those interfaces were presented to the Java developers on version 8 in 2014, and they pretty much allow the functional programming capabilities such as working with lambdas and method references. The following are some of the rules of the functional interfaces. They can have only one abstract method, any number of default methods, and they can have the functional interface annotation. The advantage of using this annotation is that if any of the functional interface's rules are broken, whenever you are writing a new functional interface, you will get a warning at compile time. As you can see in this example, my functional interface has two abstract methods. So the compiler error message is multiple non-overriding abstract methods found in interface my functional interface. One way to solve this compile error is removing one of the abstract methods. Another way to solve it is removing the functional interface annotation. But then, this will be just a normal interface. This table was tracked from the book Oracle Certified Professional Java C8 Programmer 2 Study Guide. As you can see, those are the most important functional interfaces. It is important to note that each one of them have their own particularities, such as the number of parameters they take. Some of them take none, such as the supplier. The return type. Some of them are void, such as the consumer and by consumer. And the name of the single abstract method. Some of them repeat the name of this method, such as consumer and by consumer, predicate and by predicate, and functions and unary and binary operators. This image was extracted from the Oracle certification website, and this is one of the exam objectives. As you can see, you need to have good knowledge on the Java util function package, which is where the built-in functional interfaces are located. This is a highlight of some of the interfaces we are going to cover in this series of trainings, and as you can see, they all reside in the Java util function package. So let's finally talk about the supplier. What is the supplier? This is what the supplier looks like. It has the functional interface annotation, it is parameterized by the type t, and it has the single abstract method named get. Think of the supplier interface as the factory pattern. Remember that it takes no parameters and returns something. It is used for calling methods many times, for lazy generation of values, for real-time method call, and to facilitate unit tests. It can be used with lambdas and method references as any functional interface. Let's take a look at some of the supplier examples. Some of them come from the core Java library, and one of them, the one I like the most, is from the Spring Framework library. Let's start with this one, the singleton supplier. This is the singleton supplier. It is a code from the Spring Framework. It is auto-defined as a decorator class that caches a singleton result and makes it available from the get call, just like the supplier. It looks a lot like the normal singleton class, with the difference that it is parameterized by type t. That means you can have a singleton instance of any of your classes without having to write all of the singleton verifications and checks. Let the singleton supplier do it for you. The next classes that use the supplier interface will be from the core Java library. The core Java library has evolved a lot with the use of functional interfaces and lambdas. For instance, the thread local class, which is present since Java version 1.2, released around December 1998, has been changing a lot as the Java library evolves. First, with the use of generics since JDK 5, and now you can see it using the supplier. In this method, the class is creating a new supply thread local with a no-null supplier instance, and getting the initial value using the supplier get method. Okay, for this live coding, I will start with this class supplier example, and I will create a main method, and I will also have a void print anything method. That for now we will receive a string. It can be anything. Alright. I also may make this method static, so I can call from the public static void main method, and I will print anything. Okay. Let's start with a local date time. Equals local date time, the current time, and I will print data dt dot toString. Okay, and here what I have to do, and print anything. Okay, no big deal here, nothing new. And we'll print the local date time from it. Okay, so what I want to do with this method is that it will receive, besides a string, I will receive a random number, I will receive an object class. Okay, so let's keep writing those. So let's pass a double random number equals math.random. Okay, and let's duplicate this line, and what I have to do here is random toString. Okay, let's do another one. I have a user class, and it has a public constructor that receives an age and also the name of the person. Okay, and it has a toString method, so let's duplicate this one, and I will also print the user. Okay, nothing new here. Let's run to take a look what happens. Alright, we printed my local date time, the new value, a new random number, and the user, age 30, name and Bob. Alright, but take a look at this, all of those toString in this case, and what is the problem here? The problem is, if I have one of them being null, I'll get an exception, right? Yeah, here we go. I get an exception there. So how can we prevent this and also have a delayed execution of the values? Because the local date time, we're getting the variable at the declaration. Okay, so the local date time that is getting printed is the local date time from the initialization of the value. But I don't want the local date time from the initialization of the value. I want to print this same value at this method, but at the time it arrives here. Alright, so if you were talking about delayed execution, hence the supplier will come into play. Okay, so let's start changing this method a bit so we can receive a supplier. Okay, let's receive a supplier of a string, just to start with a supplier of a string. Okay, let's import the supplier, and here we go. And okay, for the double random, the user, and local date time, they're all parsed to string, but what I need to do here is parse then a method. Okay, it's receiving a supplier, so either I pass through a lambda, okay, because it is a function interface, and let's take a look at what happens here. Aha, I'm printing the supplier representation, but what I need to do here, use the get method. Alright, here we go, the same thing. He printed the timestamp, he printed the random number, and he printed Bob age 30. Okay? Alright, but we have a problem here. We are passing a string method here. We have a supplier of type of string, so we always have to parse this to string. But we don't want to do that, right? What we want to do is have a generic method that we can send anything that we want to this method. Okay? So in order to fix this, let's make this a type T, and the method is also generic T. Okay, let's see what happens here. Alright, great. Alright, so we don't have to parse to string anymore, right? And this is the beauty of it. We start simplifying the methods that we have. Here we go. Same result with, of course, a new timestamp and a new random number. Alright, let's make this even better. Let's wrap those guys in a supplier. Let's make them a double supplier. Okay, let's make a user supplier. And let's also make a supplier of the local date time. And we can also change this to those two method references, right? They look even cooler. Right, so as an example, I could do this to all of them, right? Okay, so in this case, we don't need to pass them through a lambda anymore, right? We just pass the LDT. We just pass the random, and we just pass the user. Here we go. Let's see if this works. Here we go. We have the timestamp, we have the random number, we have Bob, age 30, printed here. Okay, but I told you guys that this local date time is the local date time of the delayed execution. All right. Now that we wrapped this guy into a supplier, the local date time now is not executed here at declaration. It is executed here when we do this anything.get. Okay, and the same goes to all of them. The math random number, now that it's wrapped in a supplier, it is not executed here. It is executed here when we do the get. Okay. And just to give you an idea, what I want to do here is having the local date time waiting 10 seconds on a thread, so you can see the difference of when it is created and when it is executed. So let's implement runnable here. And let's add the run method. And let's copy all of this to the run method. Okay. And since we are only the example I'm going to show you now is just about the local date time, I will comment out this guy, also this guy, and I won't print you and you. Okay, let's make it all about the supplier now. Okay, so let's print the local date time at the declaration, okay, of the thread start time, and let's do ldt.get. And also when we print, let's do a thread end time, and print what we get from the supplier. Alright, so let's start the thread. Let's make a new thread. T1 equals new thread. And let's pass the new supplier example. Okay, let's start the thread. And what we want to do here is, before we print anything, we're just gonna wait 10 seconds. So let's get the thread, the current thread, dot. Let's sleep for a little. Okay, and this is the 10 seconds representation. Now we have to wrap this in a try catch, because we might get an error, we might get an exception. And here we go. Let's run this method, see what happens. Alright, so this is the thread start time. We're gonna wait 10 seconds. As you can see, this is the time that we got the local date time now, okay? And then 10 seconds later, it printed the new result. It printed here, anything.get. So as you can see, we have the delay execution. I'm getting whatever I pass through this method, I'm getting at this exact time. So the same would go for the random number, the same would go for user Bob, the same would go for anything. Okay, but let's make a practical example here. I don't want just to print and have this void method. What I want to do is, besides printing, I want to return this number, because I want to do something with this value. I want to do something with this supplier. Okay, so instead of making this void, let's make this t and actually returning the supplier. Okay, so let's have this t value, which can be anything, any type, and let's do the anything.get, and we get whatever the user of this method passed it through, right? And then now we return the type. Here we go, and we print the type, so we have consistency between the calls, right? So I'm returning the type, okay, but this method doesn't know the type, and since this can be anything, what we can do here is, let's say that if we have the local date time, we send this guy to the database, and if we have the random number, we add more numbers and pass through somebody, and if it is the user, we send to the REST API, to a REST interface, okay? And so what we do here is, let's make an if the type instance of, in this case in our test is local date time, then we do anything. And for now, let's just print and say that type is a local date time, right? And then again, we could do all of the types that we have, that we are expecting, and pass ahead, right? So let's see what happens here. Then again, we started the thread start time is going to sleep for 10 seconds. It will see what the type is. If it is of local date time, it is, type is a local date time, and then the thread end time 10 seconds later. Okay guys, this live coding wraps up the supplier. It is very useful if you know how to take advantage of it. So if you like this video, give a thumbs up and don't forget to subscribe. I'll be sharing the sequence of the building functional interfaces and also new Java content. Hope you have a great day.